morning class, we're going to continue using proportions to solve. So we solved with proportions yesterday. We solved it by cross multiplying. Now we're going to look at similar figures and do the same thing. We're going to set proportions to solve. So first of all, similar figures are figures that have the same shape, but they're not the same size. So it's, for example, we have a triangle here. This one compared to this one. Obviously this one's smaller, but they're similar in the fact that they'd have the same angles. All right, each angle would be equal to one another. So if this was 110 degrees, this would be 110 degrees. So all the angles would be equal. And then the sides would be proportional. So if this were 2, this one would be 4. And you can multiply each of them by 2. All right, so this is like a blueprint. It would be a great example of where similar figures are drawn. So you make out a blueprint. It's not the exact size of the house that you're building, but it's going to have a proportion of what it should be. So what it's saying is, in similar figures, corresponding angles are congruent. So angles, those are in the same position, are equal, and corresponding sides are proportional. So if I come here, we want to list corresponding sides and angles. So if I come here, my angles, that would be, so angle C, what side is that, or what angle does that go with in this figure? Well, angle C and E go together. B and D are equal to one another, and A and F would be equal to one another. So we'd say that. Now, what sides are proportional to one another? Well, BC would go with DE because they're in the same position on the triangle. Then we'd say AB goes with side DF, and then lastly AC would go with FE. So we'd say that those are similar to one another. I should put similar signs between each one. So what we're going to do now is we can set up, now if we know corresponding sides are similar, they set up a proportion, we're going to go ahead and do that. So we'll use the same figure that we have. Side 3 goes with what side over here? Well, it went with side, this BC went with ED. So we go 3 over 7, and then 9 and x go together, so we go 9 over x. So just make sure we're consistent. 3 is from the smaller triangle here. 9 is from the smaller triangle. 7 is from the larger triangle. X is from the larger triangle as well. And they're the sides that are in the same position. So now, how do we set up a proportion? Cross multiply. 3 times x is 3x. 7 times 9 is 3. Then we go ahead. How do I get rid of 3? Divide by 3. So x equals 21. Come here. Figures are similar. Find the missing length. So let's start with this. 8 goes with what side over here? Well, it goes with 20. K goes with 12.5. So we'd say 8 over 20 is equal to, 8 over 20 is equal to K over 12.5. So then we cross multiply. Again, this should be K. Something went wrong there. So 20 times K is 20K. 8 times 12.5 is 100. Now we go ahead. How do we get rid of 20? Divide by 20. So K is equal to 5. Same idea as we go forward. A tree casts a 26-foot shadow. So I just draw that. A tree casts a 26-foot shadow. So this is the shadow on the ground. A boy standing nearby casts a 12-foot shadow. So a boy, 12-foot shadow, right? His height is 4.5 feet tall. So we want to know that. We want to know how tall is the tree. So what do we have now? We have similar figures. We want to go ahead and set up a proportion to solve. So we go ahead and we could say however you want to do. So we could say 12 over 26 is equal to 4.5 over x. All right? You can go 4.5 over x is equal to 12 over 26. Cross multiply. You could simplify this first if you want to, but we could just cross multiply. 12 times x is 12x. 26 times 4.5 would be 117. Now, divide by 12, and you get the tree's about 9.75 feet. So that's what we're looking for. That's what we're trying to do. Now, we want to go ahead and this is like a, so use the following scales, find the dimensions of a blueprint. So we have a blueprint. We know the room's 8 feet by 12 feet. What is it, how big is it going to be in our blueprint? So if it tells us 1 inch is 2 feet. So we set up a proportion. This right here is the proportion given to us. So we can say 1 inch is 2 feet. So we look at each side. Okay, so we're going to start with the side 8 feet. Is equal to what? Over 8 feet. So we know it's 8 feet, so you can see feet are in the denominators. Inches and inches. That's what we're trying to find. So now we cross multiply. 1 times 8 is 8. 2 times x is 2x. Divide by 2, and we'd have 8, x is equal to 4. Again, that would be in inches, 4 inches. Go ahead and do the same thing with the other side. So 1 over 2 would equal blank over 12. So here's our other dimension. Cross multiply. 1 times 12 is 12. 2 times x is 2x. Divide by 2, x equals 6. So what we've gone to is the dimensions. The real room is 8 feet by 12 feet. Our blueprint would be 4 inches by 6 inches. That's what we do. We have to do it for each one. So that's our lesson for today. So similar figures, we're going to set up a proportion to solve it and go from there.